This video is a review of subnetting an IP address. It is recommended that you are familiar with the basic concepts of subnetting and binary numbering prior to watching this video. As humans, we read the IP address in a dotted decimal notation. An IP address consists of 4 octets. Computers, routers, and other network devices read these octets in binary. Each binary digit in the octet carries a specific weight or value. This is the binary truth table. It shows the binary weight of bits in an octet. Cisco, Microsoft, and others use the formula 2 to the nth power equal to or less than 2 to find the value needed to support the number of hosts or subnetworks. This is the powers of 2 table written out in a linear fashion for finding the number of subnets or hosts. Host bits can be borrowed from the left for calculating the number of subnets. Host bits are retained from the right for calculating the required number of hosts. Always start from the left of this table. 1 bit equals 2, 2 bits equals 4, 3 bits equals 8. This is a placeholder. For hosts, remember to subtract 2 addresses, one for the network ID, one for the broadcast, because these are not assignable to a host device. The slash notation is a way of representing the subnetwork mask that indicates how many network bits, ones, are in the subnet mask. For example, a /8 equals 8 bits, a /23 equals 23 bits. You write out the given mask in binary form, whether it be the default classful mask or a subnet mask. Given the IP address of 187.10.35.0/21, you'll find that this is a Class B address that has been subnetted, so it is classless. It's not a /16. There are 21 network bits. Remember, network bits are on the left, host bits are on the right. Always. Calculating hosts. A /21 is your given mask, so when written in binary, the subnet mask is displayed and represented in the dotted decimal notation as 255.255.248.0. If, for example, you need 55 hosts, using the powers of 2 table, count 6 places from the left to reach 64. You would not be able to reach 55 from any number less than 64. Then on your binary mask, you count 6 zeros from the right for the host bits. The remaining 5 host bits are turned into network bits, thus giving a new subnet mask of 255.255.255.192. You take the value of the octet that is less than 255 and subtract that value from 256. This will get the interval, also known as the range of addresses, for each network. So if the new subnet mask is 255.255.255.192, take 256, subtract 192, which leaves the interval of 64. This is the range of IP addresses for each subnetwork. Apply the range, starting from the .0 for the octet where the mask changed, in this case, the 4th octet. Remember, the given IP address was 187.10.35.0, but now carries a /26 mask. This is the network address, the host range, the broadcast for each of the 4 networks with 62 hosts per network. Calculating networks. You're given the IP address of 187.10.0.0/17. Notice that the /17 is your given mask, and when written out in binary, the subnet mask is displayed and represented in the dotted decimal notation as 255.255.128.0. If, for example, you need 14 networks using the powers of 2 table, you count 4 places from the left to reach a value to achieve 14 networks. Starting from the left this time, the borrowed 4 host bits are turned into network bits, thus giving a new subnet mask and a /21 notation. The new subnet mask is 255.255.248.0. You take the value of the octet that is less than 255, subtract that value from 256. This will get the interval, also known as the range of addresses, for each network. So if the new subnet mask is 255.255.248.0, you take 256, subtract 248, which leaves the interval of 8. This is the range of your IP addresses for each subnetwork. Once again, you apply the range starting from the .0 for the octet where the mask changed, in this case, the third octet. Remember, the given IP address was 187.10.0.0, but now carries a /21 mask. These are the network ID, host ranges, and broadcast for each of the 16 networks.